Hey guys, this is a 1976, I believe, Sprint 2 by Atari. This is a pretty comprehensive video. I got a lot of analyzer work in this one and stuff like that. It's a very long video. This thing had a ton of stuff wrong with it. So if you're into that kind of stuff, stick around and enjoy the video. Hello everyone and welcome back to Classic Arcade Repairs. Getting ready to start a new one. This is Sprint 2. It's dirty. It's very dirty. And it's missing the filter caps. It's got a big old ugly socket on it. Sprint 2. The amps look good. They're there. They're original. I got a couple caps out. These are originally 8,000. I'm going to put two 10,000s in. So you got to filter that. You got to filter that AC that's rectified because this gets AC in. This is all soldered up on. That's got to be cleaned. I'm not putting that in my edge connectors. It'll ruin the edge connector. If you have to build up solder on your pads, then you need to replace your edge connector. Long-term fix. This is a short-term band-aid that just is not good. So I'll be doing that, removing all of that. We'll test the voltage, make sure it's good. If it's creeping up over 5 volts, I like to replace these. But if it's around 495, that's fine. As long as the game's acting normal. Sometimes these will put out a good voltage, but the current is not constant. And you'll get weirdness in the picture. So if you see that, then that needs to be replaced. But if the game plays good and it's a little bit under 5 volts, I'll leave that. It's a good original number, LM323K. This board needs to be washed though. This one is filthy. So yeah, it's got a nice old ceramic. And I see a broken leg on it. Yeah, this thing's no good. It's got broken legs on it. I'll remove it to look at it, but alright. Let me I think first things first, I'm going to remove these pins. Somebody scammed these. Somebody decided that since this didn't work, they were just going to take these off of it. So these have been clipped. This one's cut near, just cut off. Yeah, interesting. Okay, let me wash this thing up. I'm going to wash it up. I'm going to replace this socket first thing before I even turn it on. This socket's got to go. Clean it up, put caps in it. I'm going to replace probably both of these diodes. And just do some general making sure everything's soldered nicely underneath here. And then we can start working. Yeah, I pulled this 6502 out of it, and it's missing a ton of its legs. This thing's date coded 1977. This is probably one of the first 6502s. I may have read somewhere along the line that these ceramic first run chips are worth some money, but this one is obviously pretty beat up. We'll be replacing that. So yeah, I just wanted to point that out. And after a good cleaning, this is what we're end up with. Got our board here nice and clean. I've removed, those diodes were cut in half, both of them were cut. I removed both of those, cleared the holes, I removed these pins, I removed all the solder off of these, and some of them, they're going to have a little bit of replacement done, a little bit of work. I'll put new caps in it, new diodes, really fix up this edge connector. It's got a couple right here that are missing, so a little bit of edge connector work. I removed all the solder off of these. Removed all of this stuff. Yeah, so I'll resolder this resistor here. And we're cleaned up at least, so we'll move on from there. Okay, I did the edge connector repair. You see these two right here on the end, not quite the end. That one and this one are new. And then on this side, that one, and that one, the three right here, those are replaced. So we got a new edge, new diodes, and caps. I drilled a hole right through there to hook the positive of that cap. So, and this one is actually axial, connected right there. So we have 20,000 microfarads filtering that lower voltage. So that should do good. So let's plug this thing in and see what we get now. Well, I got it all hooked up and just realized I got to put a CPU socket in it. So do that, put a CPU in it, and then we can fire it up. You know what, I can test the voltage. I'll test the voltage right now. Okay, so if I test both of the amps, I'll turn this one up. I get a little sound. That sounds good. Turn this one up. I get a little sound. This one is pretty low. I don't know if it's supposed to be higher than that. It's doing something. But if I test my voltage, and this is ground right here. It's a little low, 4.69. Huh, interesting. Anyway, yeah, it's a little low at 4.69. So I am going to replace that regulator. And while I'm doing my soldering stuff and putting this in, I'll change that. Okay, I just took this off, and I don't really like how this is. I cleaned it up as good as I could, but this is your common connection right here. Those are fine, but this one right here, you see how the tin goes around the hole? I got to make sure I get a good connection there. This one doesn't matter. I just didn't want this shorting on anything. This one I need to make sure that the ground gets a good connection here. So this thing had the screws going down through the board. I'm going to do it how they normally are, and the screws going up through the board. That way I can kind of solder the screw to the track here. to make sure it's getting a good ground. So I'll go ahead and put a new one in, clean this up a little bit, and this was not put in correctly in the first place. These are supposed to go down on the bottom of the board. They were not on the bottom of the board. They're supposed to lift this up off the board a little bit, and they were not. They were on top of the part. So yeah, I don't know. We'll fix it and fix it right. This one I'm going to throw out though. We'll put a new one in. Right, yeah, I got that in there really good. I was able to reuse that silicone heat sink thermal pad. It looked really good. It was still pliable and flexible, so I went ahead and reused it. I got that tightened down really good. And we'll go ahead and solder these really good. And then I want to try to run some solder between this screw and here, because I'm not so sure that that's actually getting a good connection. So we'll take care of that, even if I have to get my really big soldering thing out to do that. And it doesn't really matter if this is made permanent, because you can still remove the nut off of the regulator, and who knows, you may never have to change this again. But at least let's get a good connection on it. Alright, I had to actually get the big dog out. That's my chassis gun. Soldering directly to chassis, monitor chassis and such. And got a good connection around that screw. So now we know we got a solid ground. Not going to be an issue. And now we're all cleaned up. Got a good ground. So let's see what our voltage looks like now. Alright, we're ready to go. I got a socket in there. I got a new CPU in there. A new regulator. In good. Cleaned up. Let's see if I can kind of rig this. Got ground right there. Be right back. Alright, I just got the ground lead kind of rigged into that cap, and we're going to turn it on. Put that on volts. Let's see what we got. 510. And you know what? I measured across this resistor, and it was reading like 8 ohms. Well, it's pretty good and quiet anyway. What do you think? Is it going to come up working? Nope. Negative. Negative, Ghost Rider. Okay. But did we expect it to? You know what I want to do? I want to revisit this. And I want to revisit that and make sure that's a 4 ohm resistor. If you go up in I might have to go higher on that. I might have to go higher on this. I don't know. We'll see. We'll see what's going on. I don't know. I don't really like that it's at 5.7. I guess that's no big deal, but still. I like it around 495. If you scared me to death. That made me jump. That was a jump scare and a half right there. Yeah, I might have to go up on that. So if you can raise the resistance on this, and your voltage will go down a little bit. So if, I don't know, we'll see. You can put like a, I don't know. If I put a 22 ohm in there, I don't think I have anything less than 22. I might have a 10 ohm. That would work probably perfect. It'd be nice to lower that a little bit. I don't really like that. It's not bad. 506 is not bad. It's better than 4.70 or 4.69, whatever it was. But we're not working. It is not working. It is not working at all. And this has those 2102 RAMs, I think. I think that's what those are. And we can surely, at least it's synced. That's good. We got sync. We can surely check our program. And we can check our RAMs with the Fluke. So why not do that? But before I do that, I'm going to see what kind of power resistors I have. I thought I bought some at some point. Let me look into that. If I've got a 10 ohm, 10 watt, that would be great. That would bring that down to about, it'd be under 5 volts anyway. So let me check that out. Okay, yeah, I put a 22 ohm resistor there. And that has gotten us almost to 5 volts. 502, 503. It's better. I'm going to leave it like that. Interesting. Okay, yeah. I was experimenting. Okay, yeah, all right. So we got voltage under control, a little bit better. Now it's time for the Fluke. Okay, Saturday night. You have to pardon the noise. I got the just fan blowing in some nice cooler air, and I got the door open because it's cooler outside than it is in here. I hooked the Fluke up to this guy. I did not record, but on my bus test, I was getting bit 4 tied high. And when I probed on pin D4, which is D4 E3 pin 11 from the CPU. E3 pin 11 from the CPU is right here. And I don't know if you can see, but I've got it clipped. And now, of course, it's just high. But you could see the signal riding high. So I clipped that, I looped that, I put it on a loop. And it said bit 4 tied high loop, and I hit loop. So it was looping it. And I clipped that, and it did not clear. So I was like, okay, where's the next place I see data bit 4? And I saw it right here. There's D4, right there. That's 367 at E6, pin 9. So I clipped pin 9 of E6 and it cleared up. So I have to replace that 367 and this 04, and then we can see what we get. Okay, so I replaced those two parts, 367, 04. And I did checks on all of the ROMs. The ROMs are all good. Now I'm testing RAM, and as you can see on the RAM, I've already found the bad RAM. And I'm going to show you how I found them. If I just go into this and I do a RAM test, I have notes here because I've repaired Sprint 2 boards before, and I write myself notes. You can test all of these individual ranges, but you'll get funkiness with the Fluke if you try to do the whole range from 0 to 3FF. So just do them individually. Well, if I start right at 0 to 7F, okay, RAM short 0 to 7F. I get an error, 2.6. If I loop that, you can see it's kind of going bananas. The 2 is stationary, which tells me that there's one bad bit in the upper 4 bits. And there's more than one bad bit in the lower 4 bits, because it's going bananas. So I just start jumping RAMs. Come to this one, and I'm looking for a change, right? And I'm going to do it how I did it. I already know which ones are the bad ones, but I'm going to show you how I look at it. I do the first one, and I look at my result. No change. That's not the RAM. I come to this one. Jump it. No change. Okay? I jump this one. Alright, the 2 went away and we got a 0. That means those bits are all good now. So I know this one was 1. So I get my next RAM, I continue jumping. And I get no change. I come up here, jump, no change. Remember, it looks like 6. It's going between 6 and something else. Now I come to this RAM, and it's getting better. It's going nuts now. So that tells me there's a change there. So that is most likely a bad RAM. So I grab another RAM and I keep jumping. Go to the next one. I gotta put some tension on the legs. See how it's going 0? This is a different style RAM. Let's grab this one. Well, let's try this one. There's no change there. It's this one because I can get it to... See how it's going to 0? It wants to go to 0. That's how I can tell that that's my last bad RAM. So I'm going to replace those 3 RAM chips. And then we'll see where we're at. Okay, I got those 3 RAMs replaced. Fluke back on it. Doing a RAM check. And much to my chagrin, it's just flaky. Decode error, decode, decode. Let's try RAM at 80 to FF. Decode error. It's just got decoding errors, so... Well, we have a 9301 right here. That is the RAM signal. Working RAM comes off of this one. That's a bipolar ROM. It's probably fine. Maybe it's not, I don't know. I would say that's probably okay. I would suspect this 9301 before that, or something down the line activating the RAM chips themselves. So yeah, it's a little late. I'm gonna just end it right here, and maybe tomorrow's Sunday, but I may still come out here and mess around with it. And we have flakiness. See, it wants to work. Oh well. Okay. Where is that 9301? Where is that thing? And what else is it? Collision, RAM, display. It's at D2. A, B, C, D. It's this guy right here. R2D2. All right, yeah, I don't know. We'll see tomorrow. All right, actually, I decided I jumped this 9301 and there was absolutely no change. And I was like, well, I probably just got bad RAM that's goofing up the addressing. So I'm on RAM short at 80 to FF. And it gives me that if I loop it and I put chip over there, loop. Okay, there's zeros. And repeat. Oh, come on. It was working. This RAM's bad. I don't know. You're just going to have to trust me. It was working. If I remove it, it's an error all the time, pretty much. No, not. Yeah, this sucks. But if I jump it, it's okay most of the time. See that? There we go. You got to have it just right. Yeah. So this chip's no good. And then at, RAM at 0 to 7F, it gives you that. And if you loop that, it's got a decode error. It will go bananas when you jump this one. Oh, now it's just okay. See how it's going crazy? If I remove this, it'll just go straight error. Oh, now it went okay. What's going on? Decoding. Okay, decoding error. It should go bananas. Or go okay. Error. Okay. Error. Now if I jump the other ones, it doesn't do that. It's only, not this one, this one. See that? So we have two more bad RAMs. This one and this one. These two. So I'll mark those red dot on the corners here. And I'll replace those tomorrow. I'm not messing with them tonight. So, alright, good night. We'll see you next time. Probably tomorrow. Alright. We're back Sunday morning. Early. I just replaced those two RAMs. So we're going to go through our RAM check. It looks like we can do 400 to 7FF. That's video. So let's do RAM 400 to 7FF. So far so good. That's good news. Yep, good. And these ones you have to do separate. So we'll start with 0 to 7F. Okay, all right. The next is all right. And the last one. All right. And my note says you cannot do a test from 0 to 3FF because you'll get decoding bit 7 error. Let's try that. Yep, there it is. All right, cool. All right, so let's turn this thing on and see what we get. Dang, that don't sound good. Let's just try run. Yeah, nothing. It ain't working. Well, our RAMs are now good, and I know the ROM's good. So we got the RAM and the ROM working. Right? RAM. Huh. Yeah, this thing's still messed up. But at least we have this going now. We have good RAM, good ROM. Okay. So I'm going to put the fluke away, and we're just going to have to do some poking around and find out what else is going on this thing. I think that this board has a lot of bad parts on it. So we're just going to have to start poking around now. But we do have access now. The CPU has access and can successfully read the ROM and read and write to the RAM. So that's good. We got that out of the way. Now it's just a matter of finding stuff that isn't correct. Logic. Alright, so probing pin 40 of the CPU. It's low all the time, which means we are stuck in reset. So I'm going to look at the reset circuit, which is right here. It consists of a 90. I'll look at the signals coming in on pin 2 and 3. Pin 6 and 7 should be low. 6 and 7 should be low all the time. And high, a 1 and a 1. 2 and 3 should be high all the time. 2, 3, 6, and 7 should be, well, 2 and 3 should be high, 6 and 7 should be low. Of the 90 on C6. So C 1, 2, 3, 4, 5, 6. Right here. Is that it? Right here. 2 and 3. What did I say? 2 and 3 should be high all the time. And they're low all the time. And 6 and 7 should be low. Six and 7 are low all the time, and they should be low all the time. So 6 and 7 are correct. 2 and 3, in order for this to operate properly, timer reset should be going low, right? So that should be high all the time. Test should be high all the time. And timer reset, I would imagine, should flash, should be a blinking signal. High, low. So that would be two highs to get a 1. So 2 and 3, it seems. I mean, timer reset, is that something that only occurs during a reset? So maybe these two should be low all the time, 2 and 3. 2 and 3 are low all the time. So maybe that's how it's supposed to be. So let's check out pin 11, which is the output. 7, 8, 9, 10. 11 is high all the time. 12 is high all the time, so it's not counting. What about 14? 14, there's a bad signal. That's a sync signal. That's actually 128V. That's 128V right there. So 90, the 90 there isn't doing anything, and it should be counting at least and then resetting. The least significant bit, it seems, should be counting and then resetting the thing or something. I don't know. Anyway, that pin 14 there, 128V, that's what 128V looks like right here. And that's a sync signal. That should just be a constant square wave. So we need to go back all the way back to the sync section of the schematic. So let me find that and I'll be back. Alright, here's where 128V comes from. 128V comes from M3. And that's this guy right here, the red dot. Well, the first one is L3 is the first of the vertical sync chain. That's this one. So its outputs are that, and that. So that one's good. And then we move to this guy, and its outputs are floating, 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 floating. So that one, yeah, that one's completely dead. So we will replace this guy. 161. Alright, I got that replaced. 161. What do you think? Is it going to come up on the screen now? We'll see. Let's give it a shot. Yeah, it looks like we still got some sync issues. I wonder if this stupid switch needs to be flipped again. Nope. Nope. Okay, so we just have an issue with sync apparently, still. So, this thing I was going to use the oscilloscope on this. And my hard disk, my compact flash hard disk that I put in has failed. it has failed. Let me see if I can, well, I can't do anything. Yeah. I can't do anything. I do have the discs to run this. I wonder if the hard disk on this can be formatted. I'll have to load the system and try to reformat this hard disk. Maybe it just got unformatted somehow. I don't know. It's a compact flash, and it's failed, unfortunately. I'm going to try that before I tear this thing back apart. I do have an actual hard drive that would plug right into this. I have an original IDE hard drive that I could use, but I really don't want to tear that apart. So first thing I'm going to do is load the system file and see if I can't just format that thing again and reload it. That's the first thing I'll try. Anyway, that's for a different time. I'm going to use the little scope. I like the oscilloscope on this because it's just better and it's more crisp and clear, and it gives you a better reading of what's going on. Don't get me wrong, that one's not bad, but that one is not that. It's just not. So we got no sync, so I got to figure out what's going on here. So I'll get the sync part of the schematic back out and just probe through that sync section. See what's going on. And I'm going to test my reset line. Alright, I'm looking at this R2. It's a 9316, which is a 161. And what's kind of weird about this is pins 7 and 10 are both grounded, which means this will not count. I guess this is a function of the 161 that I've never seen used. And I'd have to look at the data sheet to see how this is working. The reset is not connected, it's pulled high. So basically what it looks like they're doing, does the load override pins 7 and 10? I didn't think so. I didn't think it did. I thought, well, maybe, I don't know. This will not count. It will not count. Maybe it'll load, but it won't count with 7 and 10 grounded. So maybe it's just loading and sending these signals over to this side. Anyway, if I look at the inputs on this side, it's pins 3, 4, 5, and 6. And that's this chip right here. If I look at 3, 4, 5, and 6, here's 3. There's 3. And that is horizontal and vertical sync. That's basically compositive sync. That's negative compositive sync right there. And here's pin 4, which is going to end up being on the other side of this chip. This is positive composite sync, or composite blank, I'm sorry. This is composite blank. And here's pin 5. Pin 5 is floating, and that is supposed to be display 7. So display 7 is non-existent. We're going to have to find that. And pin 6 is 256H. So that's fine. And we have our load signal right here. That's our parallel load. And our outputs are this. This is pin 14, which is supposed to be composite sync. And it's nothing. 15 is nothing, and that's supposed to be, or not 15, but 13. 13 is supposed to be that composite blank. 12 is supposed to be playfield. And then 11 is supposed to be 256H, just straight through. So we have two issues that have arisen here. One, this chip, this 161 is bad. Two, we have to find display number 7, because that was floating, remember. So I'm going to mark this with a red dot, and then I'm going to get on the schematic and find out what is display 7. Okay, I found display 7. It's L5-174, and it's this guy right here, and it's completely corroded and crusted out. And if I look at, here's the clock, here is input, output. That's output. Input, output. Input, output. This is clear, so it's not ever clearing. Input, output. Input, output. Input, output. That chip is completely blown out. Let's check this one. This one is F. What is that? It looks like the same kind of chip. I don't know. That is L6. I don't know exactly what it is. Yeah, I don't know. Yeah, it's just high. I don't know what this is supposed to be. I don't know. I probed on it and it just totally died. Yeah, I don't know. Thing just completely died. Yeah, it just completely died. Now there's nothing going on. So I don't know what this is. But when I started probing this, yeah, I think it totally just killed the clock. Oh, it's this rusted thing. Ouch. Now we have just totally lost everything. Where was that 90? This guy right here. Oh, pin 14. That's remember pin 14 was 128V. We've lost 128V again. And that came off of this. This will not count because 10 and 7 are both now. Yeah, we lost this one right here. 161. Here's, it's not resetting. Let's check 7 and 10. Here's 7. It's high. That means it will count. 10 is high. This should count. Oh, it's stuck in load. Load is low all the time, so it's stuck in a load situation. It's going to be loading zeros. So this chip may not have been. I have to go back to the schematic, find out why this, what is the load signal, because this one is not allowing this to count now. Yeah. So I need to find out what's going on with that. Okay, parallel load on these guys is pin 9, right? And it comes over to this 175 pin 11. 175 pin 11. And that 175 is at N2 012N. So it's this chip. Alright, a 175 has a clock. Nice. And it has a clear. Not cleared. Okay. Inputs are pin 4. Okay, so the input's high, so the output should be high. The non-inverting output should be high, and the inverting output should be low. And here's the non-inverting, and it's high, low, good. The next output is pin 5, or input is pin 5. Pin 5 is high, so the non-inverting output should be high, and it is. And the inverting output should be low, and it is. Okay. Moving on. Next output is, let's do pin 13. It's low, so the non-inverting output should be low, and it is. And the inverting output should be high, and it is. Next input is pin 12. It is low, so the non-inverting output should be low, and it's high. See that? Pin 12 is right here. That's the input. The input is 0. Our non-inverting output is pin 10, and it should be 0, and it's not. And the inverting output should be a 1, and it's a 0. This has a bad output, so this chip went bad. So I will mark this one with a red dot, and we have now 1, 2, 3 chips to replace. Alright, this board has a lot of this kind of, I believe that's alkaline corrosion going on the board. I think I'm going to stop. I'm going to remove all of my socketed chips, and I'm going to give this thing a nice vinegar bath and scrub it. And then after that, I might do a little bit of a Tarnex bath on top of it and scrub it to get some of this stuff clean. This board needs some help, so I'm going to do that. And I got to charge my camera anyway. It's my battery light's flashing at me, so I'm going to do that. I'm going to remove all the chips. I'm going to soak this thing in vinegar, give it a good scrub, and then I'm going to put some Tarnex over it and scrub some of these legs clean, the tarnish off of them. So let me do that. Take a little bit of a time to do a little bit of maintenance on this thing, because it's pretty nasty with this corrosion. It's pretty bad. There you go. Vinegar. I got it in this tub. Vinegar is a mild acid, and what it looks like happens over time is, from being in a corrosive environment like a damp environment or whatever, it creates an alkaline. I believe it's a base corrosion on the board. And just kind of neutralize it a little bit. Put it in a little bit of this vinegar here, and I scrub around, just kind of swish it around a little bit. You know, I'm scrubbing it, just kind of neutralizing that. Clean it up. I'll rinse it off really good. clean. Just try to get it clean. Try to help it out, maybe. Right? It smells wonderful. All right. Continue to clean this thing up. All right, I gave it its little acid bath. Cleaned off all of that just crusty, corrosive nonsense. It looks way better now. I rinsed it really good and I sprayed it down with alcohol again and used the air compressor to dry it off. But that worked wonders. That little vinegar scrub worked wonders on this board, on these traces and chips that were just over corroded. Really, really helped it out. So I'm glad I took time, stopped and did that. I forgot to remove this, and I left one of the rams in, which is no big deal, whatever. But yeah, it looks so much better. It cleaned up nicely with that. You know, and you have to get in there with it too, with that vinegar. Don't just like spray it on a little bit and scrub. I put it in a tub and I dumped that vinegar on it, and I was swishing it around in there, scrubbing it really good and heavy, and just swishing that stuff all around it to get it cleaned off. And it looks way better. So happy with that. Very nice. Neutralized all that nonsense that was just corroding this whole board. You know, that alkaline film over top of it is gone. So, very nice. Okay, I've got this chip, and this chip cut out. So I'll remove those pins, put some sockets in the board, and replace those parts and come back and see where we're at. Okay, I replaced the 161, 175, and 174. And I turned it on, and we get the pattern of the track. But of course it is not right. Yeah. So, I don't know. I'm kind of curious to hook up my black and white monitor to see what it looks like on here. See if it's stable. This might just be something with this TV, this black and white TV monitor, whatever it is. I don't know. So I think I'm going to do that. I'm going to hook up my black and white monitor and see if the picture is stable. And yeah, the picture's stable on the black and white. The actual black and white. So I don't know, there's just something weird about this. It doesn't work quite right with these old arcade hardware, so but trust me, I don't love this being up on top of there. So I'm going to remove this and I'm going to put this right there. Alright, so I got the little monitor back over here, but I think that other monitor would have been fine because I found out that the ground, this was not grounded. The ground pin just didn't make ground, so I had to ground that on the bottom of the board. So that might have been why it was funky on the other monitor, because that is a sync 161. Remember, it's this guy right here where the sync comes off of it. So that's possible that may be why that one was acting funny. But so we've got a stable picture now at least, but of course it's not correct. So yeah, I wonder what would happen if I put this in test. Will it do anything? Is there? Yeah, reset. It doesn't really do anything if I... It's in test right now. It's just kind of still just hanging out. Take it out. Yeah, it's just kind of dead. It's just like that. We see the outline of the track, right? So we're getting somewhere. I think what I'll do is just kind of start poking around a little bit and look for obvious dead signals. So there's probably a plethora of just bad signals on this thing. So I'm just going to do that. Just kind of poke around on the board. This chip right here, which I can't read, I don't know what it is. It's not that hot at all, but it's got some goofy looking signals. I don't know what this chip is, keep in mind. Look at that. What is that? There's just a floating signal. I don't know what this is. I gotta find out what this chip is. It is at K012345. K5. Let's look that up. Alright, K5 is a 367. And remember, my RAMs are okay. I can do RAM checks. But the gates that I'm questioning are not listed on here. The ones that look goofy are the output, or the input on 14, which that may be nothing. It may just be noise. But the output is to a signal. 14 out to 13. So is there a 14 out to 13 K5? And then 12 out to 11. Is there a 12 out to 11? Or are those unused gates? They may just be unused gates. But I don't understand why they would have this signal on them if they're unused. You know what I mean? So I kind of want to find if there's another K5 on this schematic for those two gates. Those two are not used in the RAM. So I'm looking for 14 out to 13 and 12 out to 11 K5. I'm going to look around and see if there is anything like that on this schematic. If not, then we can just disregard that. It's not an issue. Okay, I did find those two. K5 right here. And those inputs, remember which one is floating and the other looks goofy, come from a 153 at M8. And that is basically switch mux kind of input signals, right? So that don't work. M8. Let's look at M8. M8. 0, 1, 2, 3, 4, 5, 6, 7, 8. 1, 5, 3. Alright, we have our inputs to it. Alright. We have enable. Now let's look at the inputs. High. Remember, these are basically switch inputs. So they're going to be solid states. Maybe not on this side. For the most part they are. This one's a signal for sure, but the outputs are garbage. Yeah, that's the outputs to that thing. So 153, and it's good to get rid of that chip because it's rusty and crusty anyway. So 153's got to go. Right, I replaced that 153 right there, and let's at least check it out and see how it looks. It didn't make a difference to this. We're still just on this screen. So at least we have a signal now. Yeah, it looks better. And that comes over to this guy. And 14 out to that, and then this out to that. I'm going to take for granted right now that that chip is fine, because most of that 367 is used to drive RAM back to the CPU. And we know that our RAM is okay. We can test our RAM. So for the time being, until it dies, this chip is okay. So now we just don't have no game going on. I wonder if this thing will play like this, and if it's just playfield issues. So I'm gonna mess around off camera. I'm gonna try coining this. Well, let's try it right here. How about that? The reason why I wanted to do it off camera is because I don't really know what's what. Do I have a coin switch? What's up? We have start. Coin. Do I have a coin? Test. Track select. Gas pedal. I don't know. I don't know what's going on. I don't know what's happening. What's this? What is this? Is this coin? I don't know. It ain't doing nothing over there. Let's try start one. It says touch to 5 volts. So let's touch that to 5 volts. Where am I going to find 5 volts? Right here. Alright, am I started? Gas pedal, touch to 5 volts. I don't know. I don't know what's happening, fellas. Fellas, I don't know. It looks like I can see kind of silhouettes of the cars running around the track. But it looks like they're kind of jumping all over the place a little bit. I don't know what's happening. So, what is up with our play field? So this thing's in attract mode now. Is it? Is that what this is? That would kind of suggest that we have playfield issue, right? Playfields start with these two bipolars. Well, they don't start with it, but these are the ROM for the playfield. These two guys. So I wonder if we have bad playfield ROMs. I think I want to mess around off camera with this a little bit and try to get this thing playing. See if I can get it to play, get it to steer. I don't know. I have something called test here. Test. Where'd test go? Here's test. Come on. Yeah, I'll be back. Okay, I know for a fact now that this 9312 is dead. That is this guy right here, H9. It just is a bunch of inputs. And I know that it's dead because I've got it in test right now. I've connected the test lead to 5 volts and it's running in attract mode, which is good. But if I hit reset, it should go into test, and it's not. But if I jump this 9312 over this 9312, it'll go into test.
Hey, want to hear the most annoying sound in the world?
So yeah, if I remove it, out of test. So that one is no good. So I'll have to replace that guy. And this one is this one right here, which is also a bunch of inputs and stuff for your gearing. So I know that this one is bad. I don't know that this one is bad yet. I'll figure that out when we get into gameplay. And what is this rusted at? This thing is a rusty, crusty chip right here. What is that? I should just replace that just for the heck of it. I don't know what it is, but it's coming out of the board because it's completely rusted. So I'm going to replace the 9312. And while I'm at it, I'm going to go ahead and replace whatever this rusty chip is, I think. So it's the worst chip on the board, I believe. It is. It's the most rusted out chip on the whole board, so I'm going to replace it. I'm going to find out what it is, and it's going. Chances are it's no good. Alright, I replaced those two. That was a 156. 74 LS 156, and then the 9312. And it's cycling tracks. Okay, it's working. I mean, the program is working. Let's turn that off. These old oxidized boards. I like to have air circulating when I'm soldering. But yeah, so our track cycle is working. That's good. Track cycling. That is probably at 9312, right? Yeah. Yeah. No, that's the 156. The 156 is the track cycle. And then that goes down to that 153 that I replaced. So the 156 was no good because it wasn't cycling the tracks before. Okay. Excellent. So now when we put it into test, it's just loud and obnoxious. Because that's what it does for the sound. To test the sound, it just gets extremely loud and obnoxious. This is test right here, the black wire. I think this amp's no good. This one's fine. I think this amp's dead, possibly. Yeah, I'll have to keep that in mind. I think we have a bad amp. All right, let's take it out of test. Now we're out of test. It should go back to attract and, yep, cycling. So let's coin. Yeah, It went to start. And let's try start. 1, touch to 5 volts. Gas pedal 1. Car 2, car 1. How about, what's this? Test, start. I don't know. What's this? Track select. Start 2. Test. Start 1. You know what? Let's work on getting this thing to where we can see it. I'll worry about controls last. I want to get the play field right, and I want to get the car movement right, because you can see the cars are really jumpy. So let's work on play field number 1, and I'm going to have to remove these 2 bipolar ROMs, I believe. Let me get this out of here. I mean, they look okay. I can test. You know what I should do is, let me look at the... That's probably fine. Let's do this. Let's find the playfield stuff. CPU, we believe, is okay for the time being. Video stuff, sync, should be okay, I think. Car movement, we'll get to you later. Car movement. So this should be playfield stuff, right? This is... Alright, let me look at the schematic and find the playfield circuitry. I got to find those 2 bipolar ROMs and make sure I've got it printed, right? So let me do that. Okay, here's a couple video proms. That's these 2 guys right here. Right? And they make these video signals based off of addressing from this stuff. So what I'm looking at here is we have display signals. Remember those? We had display 7 before. But if I look at A5, which is display pin 2, display 4, pin 2 is floating. That's pin 2 of the bipolar ROMs. Is display 4. Display 4 comes back off of our RAM stuff. Right? Remember? Display 4 is this guy, F5, 174. F5. It's going to be this chip. 0, 1, 2, 3, 4, 5. F5. Clock. Very fast clock. Let's slow this thing down a little bit, shall we? There's our clock. Okay? Alright, let me pick the camera back up. Okay? Clock. Input, output. Okay, looks good. Input, output. Input, output. So far so good. That's our clear. No clear. Input, output. That's no good. I don't think that would be good. I would expect a signal there. Input, output. That looks okay. Input, output, floating. Yeah, this guy's got to go. 174. And let's check L5. Did I already replaced L5. Remember, this was the other one that I already replaced. Remember, display 7 was bad? Well, this one's bad too. These are these two guys right here, creating these display signals from the RAM bits. So, yeah, this one's got to go too. There's another chip replaced. So let's see what we got. Oh, look at that. Would you look at that? And look at the cars are moving good too. And the cars are moving good. The track looks proper. I need to change the whole vertical size on the monitor. That is one problem with this monitor, is I think I have a wrong... Uh-oh. Well, I guess that was nothing. Yeah, it looks good. You know, this monitor, I have something's wrong with the vertical size. So it is not the board, it's my monitor. I can't get it to... I have the wrong size pod in it or something. Yeah, white car's kind of going bananas, kind of going a little weird. You might not be... Nah, that white car's not right. Yeah. Okay, so the white car's acting funny.
Funny how? I mean, what's funny about it?
But it looks good. And I think this is a good time to go eat lunch and take a break. That's what I'm going to do. So... yeah, very nice. So we've got our playfield straightened away. We need to look at car motion, movement. We need to look at the amp for that one side. Engine needs to ramp up properly, you know, just controls and sounds and stuff like that. So I'm going to take a break and I'll be back later. It is Sunday and I might just call it a day and come back at it Monday. See you then. Alright, yeah, I'm out just doing some testing and it seems that I've got no control over the gas on player 2, although the steering seems to work for both. Player 1 and 2, steering seems to be okay. Player 1 just likes to go back and forth doing its own thing, and the black car won't move. So, yeah. So I'll get the schematic out, and first things first, let's get player 1, let's get the movements right. with the gas and, you know, gas moving the car, and then you can move the car and everything, and then we'll worry about everything else after that. All right, well, I'm kind of getting to the point where I might be forced to repair that, because I'm not really seeing anything that's obvious, and I'm coming up on parts that have to be analyzed. And I can't use this because my little compact flash hard drive that I put in there has failed. So, like I said, I'm going to go ahead and try to see if I can reformat it, because that would be the easiest fix. So let me do that. Alright, I put my system discs in it. I got a bunch of these. I got actually 2 copies just in case. So, I don't know. We'll see. It's loading the system file right now. I do have these backed up as well. Every one of my files I have backed up. And I made myself a video on how to do all of this. Move everything over. See, there you go. Boom. Hard disk power up test. So the hard disk didn't even power up. It's dead. So that stupid thing is dead. Okay, well, that's unfortunate. Disk error. So I can't format it. I just got to replace it. I do have a hard drive to go into this. So I think I'm going to have to clear my bench and tear this thing apart. I'm really not looking forward to it, but I need it. When I need it, it breaks, you know. I can go 2 months without using this. That's probably why it broke, to be honest. But alright, well, let's take it apart. Well, so here is my hard drive that I put in. And I noticed that this plug was really loose. So I just plugged it back in and turned it on. And it works. Yay! So I'm going to button it back up. And man, that's good. I'm so happy about that. Alright, very good. Happy Labor Day. It is Labor Day morning. And I got this thing fired up. It's working fine. I got the board on. And I've noticed that the white car, which I believe is car 1, is really goofy. And then there's another car, one of the computer cars, the gray cars, is also acting all funky. So there's just weirdness going on. And I got this thing turned on because I want to just probe some signals. I want to make sure that all of my display signals are present and good. I just want to probe these and make sure. These are the 83s. I just want to make sure everything looks fine. I'm not seeing any floating stuff. I want to go over it one more time and just make sure that nothing is floating. And then we'll start to analyze. Now, these bipolar ROMs that produce these vid signals, vid 0 through vid 7, so it's 8 bits. Those are, let's just get rid of all that. I don't need that stuff right now. They are the inputs to these 165s. Oh, no, they're not. What's the vid signals do? Oh, they're the inputs. Yeah, they're the inputs to the 165s. Those are 163s. So I would say, since we've got some cars that are working fine, that those are probably fine. I would say that it's either going to be the shift registers. These are probably fine. The 83s are probably fine, but those are easy enough to look at. We could definitely have problems with the 9301s. So those will be worth looking at. We got some easy gate stuff here. That's probably fine, but those are easy enough to look at. So the main culprits, I believe, are going to be 163s or 165s or 9301. But I want to start by just kind of poking around at stuff. So I'll do that and just kind of make sure that nothing's obvious. One more time. Before I start analyzing, I want one more time of looking at everything. Alright, so let me do that and I'll be back. Nope. P7. This guy. This one is stuck low. The first bit is stuck low, but it just so happens the first bit is not used. This is the same thing, the same functionality of a 42. It's just a different pinout, but it's the exact same function. And the 0 bit is stuck low all the time, but it, like I said, it's unused, so that don't really matter. But so this is 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. This is a 10-bit decoder. 0 through 9. So up here, if you have a letter up here, these should all be 1. The only time that you should have a 0 down here is when you have a number up here, 0 to 9. And the corresponding bit should be a 0 corresponding to what the number is, right? 6. Look at all the zeros here. This should only be the 6th bit to be 0. It should only be 0, 1, 2, 3, 4, 5, 6. But there's 3 zeros. There should be no zeros because it's 2 letters. Same thing. Here we have a 9, and the 9 bit is a 0, but so is the 0 bit. And then we have an 8, same thing. 8 is a 0, but so is the 0. Same thing. 9, 8, 3. Look at all. It should just be the 3 bit. And then you got B. B is also triggering the 9 bit. So this thing is trash. This is the problem right here. So I do have 9301, so I'll have to replace that guy. And that is this, and it's all of these LDH numbers, which are right here. They're loading. They load the 163s. So in the motion where the 163s are counting the position of the cars, it's loading at odd times and it's putting the cars at weird positions. That's what's going on. So we'll go ahead and replace that guy. 9301 replaced. And we're running, and our cars are normal. Our cars are acting as they should. Now we know, I believe anyway, that my steering was good on both the cars. I don't know about the gas or the shifting, so we have to do some tests on controls. Yeah, the cars are all good now. So next thing we do is we do our controls, and I believe we're going to have to replace this amp. So controls first. We'll do sound last. So, and in the controls, I know the shifting goes through this 9312. So that might be faulty. And then we have some circuitry for the sound. We'll deal with the sound, all that. So the motor sound and all that. Let's just make sure that our cars drive properly first. All right, well, Labor Day evening and I'm back. I hope everyone had a good cookout to go to, family or friends to hang out with, spend some quality time with. I just got back from my brother's house and he had made barbecued ribs on the grill, and he made beer brats and corn on the cob, and it was fantastic. Great, great, great. And I got home and I had an ice cream, and now I'm back here. And I am trying to put this thing into test, and it does not want to go into test. Why? Why no test? Why no test? No test?
Why? 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 Why?
Won't go into test. Test goes through H9. Self-test. H9. I replaced that, and then it comes out to this 20. So, that 20 is right here. I think. Yeah. 1, 2, 3, 4, 5, 6, 7. Yeah. Could that be bad? And then it goes through N9, which is up here, this guy. Right there. And then through to this chip that I replaced, M8. Which is right here. So, somebody has texted me. I am going to first suspect this 20. Yeah, I don't know. I'm just looking over here. Yeah. Yeah, I don't know. All right. Anyway, yeah. Let's fire this thing back up, use the scope, and start poking around, find out why it won't go into test. And I could check my edge connector too, to be honest. So I'll just check continuity from the switch to whatever pin it goes to. I'll check that, make sure I got continuity going to the chip so it's not an edge connector issue. And then we'll start probing on some chips. One thing after another. Well, oddly enough, that 9312 died. So I put another one in there. And it's in test. Weird is that? Well, not brand new, but you know, new old stock chip. Crapped out? Alright. Okay. That should take care of that. Alright. Back to it. Now I'm testing controls. Alright. Alright, I'm going to have to set up the camera and do a little bit of boring testing for you. From my initial testing, car 2, which is the black car, works. I believe as it should. The engine seems to rev up as it should, and I can adjust that, I know, with a pot. I don't hear the crash sound, or bang sound, whatever you want to call it. I don't hear that. I hear the squealing. The white car number 1, just consistently spins. It don't stop spinning. And, yeah, so that's not good. So let me put this thing up on here on the tripod so that you can get a look at what's going on. Let's drop this down. Kind of aim it down. Come up a little bit. Right. How's that? I'll go ahead and do a little testing. Start it up. First I'm just going to do, well, I'll do a 2-player game. I want to switch the dip switches to hopefully the most time. I don't know how to do that, to be honest. 9 times 0, I don't know what that means. 8 to 9, I'm just going to switch. I'm just going to switch 8, dip switch 8. See what happens. And I'm going to reset it. Okay. I'll coin up 2 coins. And I'm going to do 2-player start. Okay. You see the white car is just spinning. I can spin them the other way. The black car, that's the black car. Now I'll put gas on the oh wow, that was really short. I don't really know how to set the time, so I'm just going to have to play with this how it is. I'll give it 2 coins. I'll go to, first let's try moving around the white car. So we'll do start 1. Okay. Start 1. 1 gas. First gear. Second gear. Third gear. So the gears don't seem to do anything for that one. And it just consistently wants to turn. And the gears don't do nothing. It's like stuck in first gear or something. Second gear, I'll go to third gear, nothing. Third gear, yeah, see that one just, now I'm going to put 2 players and I'll control the black car. So we'll go 2 coins, and let me find start 2. Okay, gas. First gear. Second gear. Third. No collision. No collision detection. I can go right through the walls. Sorry about that. Okay. So now we know a few things. We know that we have no collision detection. Okay. And we know that car number 1, the gears have no effect. And the steering is jacked up. So, alright, so, and we have no bang sound. But that's probably because we have no collision detection. That sounds probably fine. It's just, it's got to be activated with the collision signal, right? So, okay, so what do we want to do first? Let's get car number 1 working properly. First things first, and then we'll work on collision and all that. First thing, let's look, and we got to go to the steering and the gears. Steering did not work. It was stuck moving, and the gears had no effect. And I know that the gears go through this for both of the cars. So I'm like, is it not working for one and working for the other? I don't know. I doubt it. I'm gonna look a little further into that, but it may just be this chip. We'll figure it out. So first things first, let's get that white car operating properly. All right, well, in the search for what was ailing the steering, this happened. Oh boy. We've got some of the screen doubled. So maybe we've got a sync line in the addressing to the screen, excuse me, type stuff. A little messed up. We could put it into test. I wonder if test works. Probably won't tell us anything. Where you at, test? Goodness. Yeah, it ain't gonna tell us nothing. It's just doubling everything, so that should be an easy find. It's just a counter or something like that. So I gotta find that. Let me fix this. Okay, we're back to this guy that I replaced, remember. And I'm looking at composite sync, which is pin 14. And that's composite sync. So I look at pin 3, which is the input to that. Oops. Floating. So, and these are sync signals, and white playfield, black playfield come up off of this. So let's go to P2 and look at P2. This guy. We have our signal there. Okay. And we have another signal here. And we have a signal there. Is that the right? That is P2. 11, 12, 13, right? How is that floating? Do we have a bad trace here? Alright, I gotta investigate. It looks like we have a broken trace or something from pin 13 of P2 to pin 3 of R2 between these two guys. Let me look into that. Alright, well I fixed that by running this little jumper from pin 3 over to pin 13 of the chip next to it. So that takes care of that. But that's not what's causing our issue. It's weird to me that we have sync on the board. That does straighten it up now. It had like a little curl wrinkle in it. With this connected, it won't have that wrinkle anymore. It'll be straight, but we still have to find out why the track is messed up. So we'll get it. Alright, yeah, we're turned back on, and with that line hooked up, you can now see the curl in the top with the letters is gone. It's straight now. So let's figure out what's going on with this playfield. Playfield's shifted goofy. Alright. I wonder if we lost a RAM. Playfield RAM, video RAM. That's possible. I might have to put the fluke on this thing again, because we may have lost one of these video RAMs, possibly. Who knows? Yeah, let's eliminate that. Video RAM. Okay. Video RAM checks out just fine. So that is not it. We can move on to a logic failure. Okay, we have the white and black playfield. This does not include the cars. This isn't the cars. This is the playfield. We have a 166. I've looked at all of this. I haven't analyzed it. I've looked at it. I fixed this. Broken trace. This circuitry right here. We got two bipolar ROMs, unfortunately. But what I want to do first is analyze the 166 with the analyzer. Verify that it's functioning correctly. Then I may have to use I'll just use the little scope or the analyzer, since I'll have it out, and actually analyze these gates. Make sure they're not letting errant pulses through. And if that all looks good, I'm going to have to remove these bipolars and test them. And yeah, go from there, see what happens. So first things first, I'm going to analyze the 166, and we'll see. Alright, 166 does not look like it's working correctly to me. I've got a bunch of, that's parallel inputs. So this is what's latched into the parallel data, the parallel input datas. Actually, no, it's not. We need a load. Alright, I'll be back. Alright, now it's all come back to me how to test these 166s. I've made myself some notes, but it was so long ago I don't really remember. I just had to kind of look at it and think about it. The best way to do this is to actually write down what you expect at QH, because that's really internally in the chip. These are latched, and we don't care about any of these. This is just what's coming into it, right? These are what's coming into it from the bipolar ROMs to be latched and shifted. See? Latched and shifted into that. And all we care about is QH. That's the only bit coming out. So you have to look at the load pulse. Right here's the load pulse. And it's loading this. It's latching this data into QA through H, okay? And then you also have output H. So anyway, I know that can be confusing, but you just have to think of QH is H. Okay, look. That sounds ridiculous, I know. You have you have inputs A through H, and then you have QH. QH is the exact same as H. Whatever is on H is automatically on QH. That's all you have to know about that. So when we load on the first rising edge of the load, when load's low, now we've loaded this, we've latched this amount, this number, into those 8 latched bits. Okay, so we latched, and remember it's lowest to highest, so it's 00111011 was loaded into that latch. So the best thing to do is to make yourself a grid and name it. Here's your pulse, and here's A through H and QH. What we're looking for, what we expect on QH. That's inevitably, is that a word? Inevitably? That's the only thing that we're caring about. That's the output. So we write down what's loaded: 00111011, 00111011. That was loaded in, okay? And then you have your pulses. Well, you have your load pulse, and on the load pulse, this is what was loaded. Then you have 8 pulses. You're going to have 8 pulses to clear out all of this, because we're serially shifting in 0. 0 is tied low on this. You see right there. We're never inhibiting the count or the shift. The shift is not inhibiting, and the serial input is always 0. So we're always shifting 0 in. And it's going to take 8 pulses to clear this out. Whatever's shifted in, whatever's latched into here, it'll take 8 pulses for it to clear out, because it's 8 bits, right? So with that being said, back to this. So on pulse, rising edge, pulse equals rising edge of the clock, okay? So on the pulse number 1, we're going to enter, it's like this: 1, 2, 3, 4, 5, 6, 7, 8. Okay? You can kind of look at it like that. Each one of these pulses enters all of these zeros. First pulse, 0 comes in. Second pulse, 2 zeros come in. Third pulse, 3 come in. And then 4, 5, and so on, so on. And this whole thing that was loaded in up here shifts out towards the most significant bit. And whatever ends up on H ends up over here. So on the first pulse, everything shifts over 1 bit. So it stays a 1, if you can see that. Basically, we're just moving everything to the right. And this one comes over here. So we shift. Now it was 00111. Now it's over here, 0011101. And this one now came over here. This one ends up over here, I'm sorry. And then this 0 ends up here, this ends up here, this ends up, you know, it's like that. Everything shifts to the right. So a 0 comes in, it pushes everything to the right. 2 zeros come in, it pushes everything 2 more to the right. 3 come in, it pushes everything 3 more to the right. and then whatever, this just disappears now. Once this shifts over, this one's gone now, and this is now taking QH. And then when it shifts again, now this is QH. This is now QH. This is with every pulse. With every pulse, what's ever on H over here ends up over here. So what are we going to expect to see over here? If we loaded this in with our first pulse, what are we going to get on QH? Here's our first rising edge after the load, right? Here's the load, and now we shift one. When we shift one pulse, everything shifts over. QH is 1. Okay? And QH is 1. Now what's our next? There's our next pulse. Okay? Now everything shifts over again. This now becomes H, so it's now H. So we have 0. And you can see that right here, it goes to 0. Now our next pulse is right here. That's our fourth pulse. Let's just cross that off so we don't lose track. Now our fourth pulse, we move over one more. No, that was our second pulse that went to 0. Now we're on our third pulse, and this 1 comes over. See, now it was 1 1 1 0. Now it's 1 1 1. The 0 is now gone. Now it's 1. So there's our 1. It went back high. And then here's our next pulse. And that is our fourth pulse. So now we come over with another 1. See, it was 1 1 1. We shift in another 0. Now it's 1 1 1. So now we're still a 1. It's still 1. So now we go to our fifth pulse. This one. And it was 0 0 1 1. Now it's 0 1 or 0 0 1 1. So it's still a 1 on the fifth pulse. You can see right there, it's still a 1. Now we go to our next pulse. This is the sixth pulse. Okay, sixth pulse. It was 0 0 1 1. Now it's 0 0 0. You know, because it was 0 0 1 with that 1 transferred over here. Now it's 0 0 with this 0 transferred over here. And you see there's our 0. Okay, and now we go to our seventh pulse. And it just shifts these two zeros get shifted 1 over. It's still 0, so it's still 0. And you see it's still a 0. Now we actually get a load pulse right here. But it loads in 0. So it doesn't do anything. The input is 0, so it just loads 0 down here and it stays 0 until this next load. Here's a load pulse right here. And what do we know about this one? Well, let's figure it out. Let's look at what it should be. Okay, here's our load. It loads in 0 1 1 0, 0 1 1 0, 0 1 1 0. Okay, so we have a 0 over here because H is 0, so we move the 0 here. Okay, so now we start shifting. We have a 0, 0, so 0. Our first pulse, it went high. Let's see if that's what it's supposed to do. So pulse number 1, we shift in a 0. Now we have 0 1 1 0, 0 1 1. So we have a 1. Right? And we have a 1. Now our next pulse, we shift in another 0. Pulse number 2. I like to just cross this one off. We're done with that. So 2 zeros, 1, 2, and it was 0, 1, 1, 0, 0, 1. So it's still a 1. And it's still 1. Our next pulse comes in. And let's cross this off. Now we're on pulse number 3. So with 3 zeros. Remember, it was 0, 1, 1, 0, 0. So we have 0. And it shows it go to 0. See, it goes to 0. Our next pulse. Let's cross this off. This is our 4th pulse. So it's 4 zeros. 1, 2, 3, 4. And remember, it originally was 0, 1, 1, 0. Well, okay, we have a 0. And it's still 0. Our next pulse, it looks like it goes high. Let's see. That's our 5th pulse. Let's cross off number 4. 5 zeros. 3, 4, 5. Remember, it was 0, 1, 1. So that 1 comes over to the output. And there it is, 1. And then we have our next pulse, which is pulse number 6. 1, 2, 3, 4, 5, 6. 0, 1. 1 comes over, so it's still 1. You can see it's still 1. Our next pulse, this is pulse number 7. Let's see if it goes low. Pulse number 7. 1, 2, 3, 4, 5, 6, 7. Remember, it originally is 0, 1, 1, so we start with that 0. Well, okay, that's 0. And you can see it goes 0. And then we get another load pulse. And it actually, so we never get to pulse number 8. Now it loads in. It loads 0, 1, 1, 0. 0, 1, 1, 0. 0, 0, 1, 1. 0, 0, 1, 1. So the output should be 1, because that's what it loaded. That's what it latched. And you can see here it goes high. It goes to 1. Okay? Boom. And we already know we're going to have the next 2 pulses are going to be 1, 0. You know, because we're going to have zeros coming in this way. And it's going to push, this 1 will be next. There's the 1. And then we have a 0 on the next one, and it goes 0. So this 166 is working as it should. So I'm starting to suspect that we have a bad bipolar ROM, which is feeding the data to this thing. So that's going to be the next thing I check, are those bipolar ROMs. All right, we're back at it. I removed these 2 bipolar ROMs, read them in my programmer, ran them through ROM ident. Turns out they are fine. So I just started poking around, probing around on the board with the little scope, and I came across a 32 right here. I don't know what circuit this is in, but pin 11 was stuck low. The output on pin 11 was stuck low, and the two outputs, 13 and 12, both had square wave type signals on them. So an OR gate, a 32 is an OR. If either OR are a 1, the output will be 1. Well, we had 1s on both of the inputs. Darn it, we had 1s on both of the inputs, so logic would tell us we would have 1s on the output, and it was stuck low. So I don't know what circuit that was in, but I'm replacing it because it was no good. So, you know, doing that right now, and then we'll get back to, you know, down the line, will that fix something with some of the controls? Maybe the collision. Remember how we didn't have a collision? No collision detection. Maybe that circuit was in the collision detection circuit. I don't know. We'll find out, though. So, something to keep my mind on, and I'll look for the collision. See if that fixed that collision issue. Okay, I replaced that 32, and you'll see the output now, which was stuck low all the time, now has a signal on it. See that? Periodically it does that. It was stuck low. So what will that be? I don't know. Let's find out. That is F0, 1, 2, 3, 4, 5, 6. F6. Let me get the schematic out and find F6 pin 11 and find out what that does. F6 pin 11. Collision. So F6 is involved in the collision circuit.
Jeez, I knew it.
All the way down through here. So that will probably fix our collision. But we still got this nonsense going on. So, okay. Well, there we go. I think we got one thing taken care of inadvertently, just by poking around and finding bad signal. All right, I'll be back. Okay, I found another funky chip. It's a 08 at N3, pin 7, N3, pin 7, no, pin 6. N3 pin 6, and it is an address. This is going to be our problem right here. It's ANDing 16V and 256H. And it's basically an address bit to the RAMs. And what I looked at was I have an input, another input, okay, and then this was the output, just low all the time, and that may be. Instead of actually analyzing the signals, I just put a 08 over it and I lift that leg and then I probe that leg, and this is what that signal should look like. Not this. So we have a missing signal. Yeah. And it probably, since it's shorted to ground, it probably won't make a difference if you jump it. No, it doesn't. See, if you jump it and then you probe it, see, it's kind of fighting. And I don't want to keep that chip on there like that. So this chip's no good. N3. Okay. Replaced that 08. Oh boy, I have not turned it on yet, so let's turn it on together. See if it fixed. I'm sure that did fix that problem, because that was an addressing bit to the RAM.
No! God, please, no! 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 No!
Oh God. Now what? Now what? Now what? Now what? There it is. Alright, we're back to looking good. Well, why did it start like that? Was it something? I don't know. Alright, I don't know. So let's... Wait a minute. We still have the white car, which goes on its own, right? Let's go ahead and start. You know what? I need to get this thing ready to go. And let's put in a coin, start player 1. And player 1 is just turning on his own. He's not moving on his own now. So let me do a little bit of playing around with this and see what's going on. Well, on a good note, we do have collision now. The black car works perfect. I'm just cruising along in first gear, and I'll purposely hit this car. You'll see the collision. Or I can hit the side. Or this guy. Screech works. Bang does not sound. I don't know if it's supposed to, though, to be honest. I thought it, when you hit the wall, I thought it's supposed to do the bang. I don't know. Anyway, yeah, so the black car works fine. The white car just sits there spinning constantly. And we have collision now. Is there a... Alright, sorry about that. This camera just cut out on me when I was getting ready to look at the schematic there. It cut out because I needed to dump all of the film off of it because it was full. And so I emptied out the camera and we're back in business. I think I figured out why the white car spins constantly. Now, I removed some chips because I was kind of pulling my hair out. I could not find anything wrong with this whatsoever. I pulled out 367, which I had already analyzed and was fine, but I pulled it out anyway because I was like, maybe it's just internally funky. I don't know. I removed the 7414 and 74 that were involved in steering, even though they looked to be fine. And I was actually had the game on. Well, I turned it off, I cut the chips out, turned the game on, and the guy still sat there and spun. And I was like, what is going on? And then we got these little 10K resistors right here. And I started measuring from this chip across these 10K resistors. And I was checking for 10K. In one of them, I got 7K. I was like, okay, what's different here, you know? Now these go, you look at the schematic. You can see here, they go up through that 10K resistor, and they're also connected to ground through these caps, 0.01 caps. There's 4 0.01 caps. 1, 2, 3, 4, right? 1, 2, 3, 4. Well, one of these was giving me 7K instead of 10K, and those guys were right here. And as soon as I removed the one that was connected to the white car signal, it went back to 9K or 10K. So I think we had a bad cap. But it didn't, I couldn't tell anything because the signal still looked good. But I think it was leaky towards ground and was messing with the signal anyway. So I'm going to put these parts back in the board, put some new 0.01 caps in, and see if the white guy still sits there and spins. Alright, I got those parts replaced. I got these caps all replaced. Let's fire it up. Oh boy, I hope it works. I did re-measure across that cap, and it's 10K instead of the 7K that it was. That was definitely causing an issue. So let's see. Hook up my... And let's coin it up, and is red car going to sit and spin? Yes, it is sitting and spinning. Okay, so that did not fix anything. Boy, I don't know. I don't know, fellas. Sitting and spinning. I don't know. I don't know what to make of that. Let me. I'll be back in a second. Let me try something. Okay, so let's think. We have our steering stuff, all of that stuff, right? Where'd it go? All right, yeah, steering. All of our steering stuff comes out, and it's latched with the switch signal here. This chip is fine, this 367, I've looked at it. It basically gives us data bits 6 and 7. So data bits 6 and 7 go to the CPU. So the CPU is then going to load something into video RAM, right? Whatever corresponds, this is telling, oh, data bit 6 and 7. The CPU says, all right, I need to read data bit 6 and 7 and see what's going on with steering, right, or whatever. And it says, okay, there's nothing going on, there's no turning, so I'm just going to write whatever into RAM, and then that'll get spit out into the motion stuff, right? Well, it goes over to the motion circuitry as a do nothing, don't move type of deal, right? Here's the data bits go back to the CPU, and then the CPU addresses the RAM, and data goes into the RAM. Wherever our data bits, where are the data bus? All right, the data bits, data bit 0, data bit 3, 2, 1, all that go into the RAM, and it writes a value into RAM. It says this is what is going on with the steering. So it gets written into the RAM, and then it gets spit out and goes over to the motion section so that it can draw whatever's going on the screen. It's supposed to draw nothing, right? Because data bits 6 and 7 say do nothing or draw nothing, whatever, draw no change type of thing. So it goes over here, goes through here as display data, right? Display data comes over here into the motion section and gets written into all of this. I think this is where our issue is going to be with the white car spinning. It's in this motion circuitry. There is something funky in here, which means, unfortunately, well, I wonder. I got 2 bipolar ROMs here. I know the display data is good. Okay. I do not know that these 83s are good, but I imagine they are, but don't assume, right? We already had, remember this chip was bad, P7. That was bad. There's something else that's bad in here, and it is nothing for me to throw the analyzer on these 83s and make sure that they're doing what they should, but I would say that they are probably fine. The 83s are probably not an issue. But I'm going to have to look at everything on this page. Everything on this page needs to be scrutinized. So I think I will start with these 83s, put them on my analyzer and look at them, and I'm not sure, but I'm guessing that they'll be okay. But it's nothing. It's really nothing to test those. And we've got a bunch of shifters over here, which suck to look at. Remember we looked at that 166? These are a lot like that 166, the shifters. Looks like it's the same as a 166, except for it has QH and not QH, right? Remember 166 had the QH, which is the same as H? Well, I don't think it is the same as H on here, because look at H is grounded. Is it grounded on all of them? No. No input, but it's grounded. So how is that ever going to be anything other than 0? That's weird. I don't know. I guess that's because it's going to latch in a 0, but when it shifts, it can shift a 1 out. But when it loads 0 every time. The only time it's active to latch is when load is low. Yeah. And if it's shifting, it can shift a 1 out to H. Yeah, that's how that works. So that's the difference between a 166 and a 165, is it's got a complementary output. So I got to look at all of those, and that's going to be a lot of doing stuff on paper again. So it's going to be very, very time consuming. 163s aren't so bad, but these ones suck. So, and it's probably one of these 4, because it's probably one of these, to be honest, because it's car 1, right? So it's probably something around in here, maybe. I don't know. We're just going to have to look. All right, well, we are to complete and utter death. And I just had the fluke on it. RAMs test okay, ROMs test okay. But it is dead. So goodness gracious, man. I don't know. I guess I'll just have to keep on plugging along. Start probing around. Who knows? Alrighty, well, I don't know. We'll I got this thing on. I forgot about this chip. I cut a chip out. Would that keep it from running though? Possibly, I guess. Maybe, I don't know. That's this guy up here. Just the gears. Yeah, I don't think that would keep it from running. Shouldn't. I don't know. Don't know. This thing's weird. I do need to put that chip back in the board though. Gosh, what a pain in the ass. Alright. Alright, so it's been maybe an hour and a half. I went grocery shopping. I decided to just leave this thing on because it went completely dead, remember? And then it just magically started working again. And I can't do anything with that. So I was like, you know what, I'm just going to turn this thing on and leave it and go about my day. So that's what I did. Went and did some things, did some grocery shopping, just hung out with the kid. Talked about some Indiana Jones stuff with my son. Hanging out. And look at this thing now. And I know I got the light off. I'm sorry about that. But this thing is, look at the cars up there in the corner. Good. Fail. Die. Please, die. Let's turn it off. I want to see, and hopefully it stays dead. Because if it comes back up and it looks normal, then that's an issue. There we go. Stay dead. These old chips need to just fail. So I'm going to let this thing sit like this and die. I'm going to leave it on for the rest of the day. So I'll come back tomorrow and we'll see what's up. Okay, it's been a couple of hours, I guess. And we've got a bad hum line going through. That might be from a chip grounded. I don't know. And we've got some random dots now. But I found out why the cars are all going crazy. We have this chip's bad right here. I was just poking around the board. And we have a high signal, a signal, and this is a not and, so you need two ones to get a 0. So we should have this signal inverted, basically, and it's stuck low. This might be the whole reason why we have the hum bars going through. I can cut this chip out and then see what it looks like, see if we still get the hum bars. So I'll do that. Okay, I replaced the 00. I replaced this chip up here, remember I cut out a while ago. And I did verify, I played it, and I verified that player 1, the white car, shifting works, but the engine ramping does not work. Nor does the bang sound, and it still spins. I'm getting to the point where this is getting to be a no fix. Because I can't spend forever on this board. You know, I'd love to get it fixed, but at some point I have to move on and just charge a repair attempt. You know, recoup a little bit of time anyway. But if I don't get this thing tomorrow, if it's not done after a solid effort tomorrow, then I'm going to deem it a no fix. The last things that I can do are try a different ROM set. I can definitely look at all of these 165s. Tomorrow's going to be a lot of analyzing and that kind of stuff. And after that, I don't know. I don't understand why it sits there and spins. I just don't know. I don't get it. So who knows? But yeah, I'll try again tomorrow, and we'll see what happens. But if I can't get this thing by tomorrow, I'm going to have to move on. Remember how it had the little dots on the playfield? The errant dots that weren't supposed to be there. One of the bipolar ROMs went bad. Does not verify. 6396. It's marked 6396. Yeah, it's no good. Went bad. So, I'm going to have to program another one of these. This guy's no good. Okay. Okay. Well, I removed these junk dip switches and replaced them with good dip switches, because those things are always bad. Replaced the bad bipolar ROM to get rid of the dots on the screen. I've run out of LS367s, and one of them that I had in the board I thought was no good, and I went in and used my TL866 tester, and sure enough, one of them was no good. So what I did was I got a Pac-Man board right here that I just have as it's just a scrap, and it's not scrap, it could be repaired, it's just a board. It's a good board. There's no damage. But I removed these 367s out of it. Cleanly, I might add. I removed all of the four 367s. And I tested them and they were all good. So that gave me some 367s. Okay. And I put those good 367s in here. Anyway, we're back to looking decent. But we still have the mystery spinning car. I coin it up and start. We still have the spinny car. Yeah. So I'm going to have to look into why that thing is spinning all the time. So if I have to get my analyzer out and go over, that's probably what I'm going to do right now, is get the analyzer out and go over all of these 165s, because they are the motion. I don't think that has anything to do with the spinning though. That's steering, and there's nothing wrong with the steering circuit. This is a mystery. I don't know. I'm going to mess around with this today, and if I can't figure this out today, I'm going to call this one a no repair and move on to the next one. 'Cause I got another Sprint 2 board, but I can't spend more than another day on this if I can't figure this stupid spinning car out. I don't know. All right, get to it. Alright, I even tried new ROMs. I removed the old EPROMs right there. That's like, maybe one of those is funky and it's just not doing right. I don't know. But yeah, I have here a little adapter that I made. These are on my Patreon page, of course. Just an adapter for these weird ROMs that Atari and Key Games used. Yeah, I made an adapter for those. Works good. Yeah, there's a handful of games that use these weird EPROMs, weird pinout. So I just made an adapter to adapt them to 2716. So why does that guy just want to spin? Why is he spinning? It makes no sense. It makes absolutely zero sense. He spins even if I take that circuit right out of the game. This page right here. If I take this steering circuit right out of the game, I clipped pins 13 and 11 on that. Or one of these maybe I didn't. I don't. Anyway, I isolated this right off of the board and it still spins. I don't know. I don't get it. I'm going to continue. I checked all of the 163s all look good. I've done 3 of the 165s. And I got, 5 more to do, so. But I wanted to stop and I was like, you know what, I got a hunch. Maybe it's an EPROM issue, and it's not an EPROM issue. So I'll put the original ROMs back in the board. Yeah. I can show off my little adapters anyway. These things are cool. And I have it in a socket. I put socket in the board, soldered a socket in the board, and then I put a socket in the socket so that I didn't destroy the socket that is in the board. If that makes sense. So, oh boy. Okay. Alright guys, well, I am going to call this one a no fix. I've spent too much time on this board. I have to move on. I cannot figure out the little spinny white car. For the life of me, it doesn't make sense. It's not the steering circuitry. It's not the motion circuitry, because that doesn't deal with spinning. I don't know. I just don't get it. So I am moving on. Sorry about the no fix on this one, but it is what it is. I've replaced. Wait, this cost me money to do this because I can't charge a full repair on it. So this one cost me money. And I'm pretty irritated, frustrated, and I am moving on. So we'll see you on the next one, and hopefully it's a lot better and a lot easier than this rusted, crusted, oxidized piece of junk. Alright, we'll see ya. I take it you guys sensed my frustration in that last little clip. I got to thinking a little bit. What happens when you have a collision? You spin, right? A little bit. Your car will spin when you get collided with. What if it's stuck detecting a continuous collision? It's going to sit there and do this, right? Collision detection. It's this 279, right? I just cut that 279 out of the board. And if I coin this thing up now and start, no longer spinning. Goodness gracious. Let me go ahead and socket that and put a 279 in there, and hopefully that fixes it. It should. Okay, we're back together. I got a new 279 in the board. Oh goodness gracious, please. Please have this thing fixed. Coin. Start. No spin. No spin. Yay. And it works perfect. I'm not done yet though. I have to still figure out this amp is dead, I believe, and this car does not ramp up. Let me put this on the tripod so I can actually play. It was stuck in collision, remember, so maybe it will work. Alright, let's give it a shot. Player 1 gas. Car number 1, first gear. Second gear. Third gear. Okay, the gears work. The sound ramp, the engine ramp does not work. There's no collision. Now there's no collision. Oh, why is there no collision now? Okay, well, crap. It looks like there's no collision now. Maybe this thing, maybe that's a bad chip. Possible. I could try a different 279, and the engine does not ramp. That should be an easy fix. No, I don't want to say that, but yeah, I'm going to throw a different 279 in here, see if collision comes back, and then we're going to have to. It was working at one point, I remember, so we'll have to figure it out. The RPM for engine 1 is working. If you can barely hear it. Right now it's topped out. I'll hit something, watch. Yeah, it is working. The problem is this amp. It's turned up as high as it'll go. That amp's dead. So that is it's one of those TDA 1004s. Okay. Well, let's replace that. And by golly, this thing I think might be done. Okay, I got a new TDA 1004 amp installed. And let's give it a shot. Coin. Start. Ooh, sound. Gas. All right, let me go ahead and put it on tripod and do hopefully a final play. Hello, this is future Sean chiming in to let you know I'm inserting a couple videos that I did after I thought that I had finished this repair. I remembered that we were missing the quote-unquote bang sound. So this is after the fact, so we're going to go back after this little short video. We're going to go back to my final quote-unquote testing, but you'll know that the bang sound is missing. So I'm inserting this right now to let you know I did fix the bang sound. So, all right, let's get back to our regularly scheduled program. All right, before I call this one good, remember the bang sound is missing. And it's right here. Bang. So I start poking around at this 08. And it's not really getting any signals to do anything. There's nothing floating. Everything looks okay. This chip right here, 75 at C4, we have an unused output that looks like that. And that is garbage. That is unused, but its complement is used, and I don't know. I just don't like that. So I'm going to replace this 75. This guy right here is going to go bye-bye. C4. That's this. Now that was pin 8. which is right there. It is unused, but it's still not good, so that chip's got to go. I'm looking at these 164 chips, and this one right here, B7, sends a signal out on 13. It's got to be a high signal because these are AND gates and they need a 1 and a 1 to activate and create this bang sound, right? A 1 and a 1 will put a high right here, which will go through the resistor. This just will change the pitch. It's got different resistor values and just creates a different current level for the pitch of the bang sound itself, right? So anyway, I'm looking at this B7 now, pin 13. First, let's look at this one. D7, the output on pin 13 of D7 comes all the way over here, and it is activating this guy for a count. It's giving this guy inputs, B7 inputs to count to. So we can start by looking at D7. Here's its clock, which looks good. Its pin 1 and 2 are basically its inputs, and those look good. And we can look at clear on pin 9. It's not cleared. That's good. And we can look at its bits. Starting at 3, we got a count bit there, a shift bit I should say. And then we got bits being shifted all the way through, all the way to 13. Here's pin 13 right here. That is pin 13 goes over to B7. B7 is right here. It receives that on pin 1 and 2. In pin 9 it is not cleared. Here's the clock, but this one has no shifting going on at all. It's stuck low every bit. Every bit is stuck low on that thing. If I take a 164 and just kind of put it over it, move this, put it over it, and look at pin 13, you see how it's kind of fighting it on every bit. This thing is shorted to ground, so that needs to go. So I'm going to replace the 164 and I'm going to replace this 75, which has that funky output on. So internally this has an issue internally, so let's replace these two parts right here, and as long as this 08 is fine, we should get our bang sound. Alright, I replaced the 164 and the 75, and we're back on, running. So this is just to test the quote-unquote bang sound, so we'll go ahead and do that. Let me go ahead and coin her up. And player 1 start. There it is. Very loud. So there you go, there it is. The bang sound has been restored. Now this thing is 100%. There you go. So I will insert these two little video clips into, I'm actually editing the video right now and I forgot about the bang sound. So I was like, boy, I better fix that and put this in here. So there you go, bang sound fixed. Now it's 100%. Okay, I'm going to restart, reset it. Let's coin up one player first. And let's get car number 1 ready to go. Okay, first gear, second gear, third gear. Back to first. Darn it. Trying to channel my inner Jackie Stewart. Okay, I'm going to reset it. Next, I'm going to do a 2-player game, and I think I'm going to try to select a different track, and I'm going to control the black car. So, let's do a coin. Okay, now let's find 2 coins. I got to do another coin. Now I need to find track select. Here it is. Let's check out a different track. This guy right here. 2-player start. And I'm going to try the RPM isn't working on player 2. It was working. Do I have it turned up? I might not have had it turned up proper. Let's try it again. Let's try selecting track again. Yeah, let's try this one. I may not have had it turned up. It may have just been I think that was player 1's engine. I think I had the volume all the way down. So let's do now player 2 start. New coin, another coin, I think. Yep, I hear it now. I'm terrible. Alright, reset. So that's player 1, player 2. Everything works now. Everything is working. And the good news is, I think I've shaken all of the issues out of this because this board has been running for a very long time. I mean, last night I ran it for about 4 hours to get it to fail. And you remember it did fail, where all the cars were up at the top of the screen. And then we had a failure here. We had all kinds of failures on this board. This bipolar ROM failed. Goodness gracious. You know what my next job is too? My next repair is another Sprint 2. I hope it's better than this one. This one looks better. This is a better looking board. This one was rusty, crusty, corroded, and grody. But we got it, by golly. By golly, we got it. So, and here's the old amp that came out of it. I'll put a heat sink on that amp right there. Just throw one of these on it. Throw one of these dudes on there. Maybe. One of those. There's two of them locked together and I can't get it apart right now. So I'll stick one of those on the amp. Goodness gracious. Alright guys. Well, that's going to do it. Thanks for sticking with me on this one. This one was tough. I was at my wit's end with this board. I was ready to throw in the towel. But we got it. I'm glad I stuck with it. And ended up getting it right. So it's got that little hum bar. I don't know. I think that's my transformer, to be honest. It's either that or it's the monitor. Alright. Well, we'll see y'all on the next Classic Arcade Repair. Bye for now.